right, everybody. I know that with sequences and series, there are so many formulas rolling around. So I wanted to put together a review, putting them all side by side here. So I thought we would do a couple examples of each kind so you can see a comparison of each, okay? So let's get a little bit of information down. You guys, an arithmetic sequence, going back to the beginning of the unit, is a list of numbers with a common difference. Okay, so what that means is that you can add or subtract to build that list of numbers. Add 2 every time, subtract 8 every time to build up the pattern. The formula for an arithmetic sequence, it's on your formula sheet so you don't have to have it memorized, is the common difference, which is the D, and then n minus 1 plus the first term. So let's do a couple examples here. I've got Desmos off to the side, but I am going to go through this a little bit faster, so I'm expecting you to be able to use Desmos to do the arithmetic for you if you're having any trouble. But we do need to be able to identify each of the terms that are plugged in here. So if I have to find a sub 28, then the n value I'm plugging in is 28. D is the common difference, so you're trying to say, what changes between each of these numbers? What am I adding or subtracting by? So what am I adding to get from -5 to 9, or from 9 to 23, or from 23 to 37? Well, it looks like the common difference here is adding 14 each time. Okay. And then the other thing I have to be able to plug in is the a sub 1 value, which is the first term in the sequence, -5. So let's put everything in the right spot. We are finding the 28th term of this sequence. I definitely don't want to write out 28 terms, so I need to understand this formula. The 28th term, way down the list here, okay, we got 14 times 27 minus 5, because n 28 minus 1 is 27. Put all that together, and the 28th term of this sequence is 373. Okay, let's try a second example. Okay, we have to find the 23rd term in this sequence. 23rd term, so my n value is going to be 23. I need to know what's the common difference. How do I get from 9 to 13 over 2, which 13 over 2 is 6.5, and how do I get from 6.5 to 4, or 4 to 3/2, which is 1.5. What am I subtracting each time? I'm subtracting 2.5 each time. And if you want that in fraction form, you could do -5 over 2. Okay. And then my A1 value, the first term here, is 9. So put everything in the right spot. Use the formula. I'm trying to find what's the 23rd term of this sequence. My common difference is -2.5. And the first term is a 9. Okay, from there, feel free to rely on a calculator, guys. Take some of the pressure off. The 23rd term of the sequence is -46. Okay, our next review topic here is geometric sequences. So the thing to remember about geometric sequences, it's still a list of numbers, but to build that list of numbers, you have to use a common ratio. So a list of numbers with a common ratio, which means to build that list of numbers, we need to be multiplying or dividing. Multiply by 2 every time. Multiply by 100 every time, whatever it is. We're multiplying or we're dividing. Here's your formula, straight off your formula sheet. Okay, make sure you jot that down correctly. And now let's do a couple quick examples. Okay, we have to find the 14th term of this sequence. So 14 terms out. Right here I have 1, 2, 3, 4 terms given to me. I need the 14th term. So here are the things I need. and n value is going to be 14 because that's what it's asking for. The r value here is what am I multiplying or dividing by as I move from term to term. So I can do this pretty easily because 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, but also recognize that the sign is changing from negative to positive. So that means I'm multiplying by a -2 each time. Okay, and then lastly, I'll need the first term of the sequence to plug in, which is -8. So everything goes straight into this formula. I'm looking for the 14th term. The first term was -8. The r value is -2, and the n value is 14. Take that on over into a calculator to help you with the arithmetic. You should get the 14th term to be 65,536. All right, one more example for us here. Try to get 2 examples of each. Okay, maybe you should pause the video and try the second example on your own and then check your work. Okay, asked for the 7th term, which means your n value is 7. Next, I need a common ratio. Now, these I can't really do in my head very well, going from 1,024 to 768. So I am going to switch over to Desmos here and help myself out. I'm going to take like 768 and divide it by 1,024. You can do this with any 2 terms, and then you'll see what your common ratio is. If I went with the 576 and divided it by the 768, I'm still going to get 0.75. So that means my common ratio is 0.75. To go from one term to the next, I'm multiplying by 0.75. And then, of course, my first term in this sequence is 1,024. So now to put everything in its right spot. A sub n is a sub 7, looking for the 7th term, where the original term was 1,024. The ratio is 0.75, and the n value is 7. Pause the video, take yourself back over to Desmos and see what you get here. You should get 182.25. Okay, so that was a throwback into finding the terms that are listed out in a sequence. We're going to switch gears here. We're going to start talking about series. The thing to remember with a series is that it's the sum of a sequence. So an arithmetic series is the sum of an arithmetic sequence. It's the sum of the numbers in the arithmetic sequence. Okay, we have a formula for that. Jot it down carefully. Notice that the sum formulas start with S. All over 2, all over 2. Okay, so I'm going to again find each part of that in the formula here. It says I'm trying to find the sum of 37 terms. Gosh, so the n value is 37. So glad I'm not doing this by hand. Next, I'll need the first term of the sequence, which is right here, -3. Okay. And then, whoops, that's an n. And then I'll need the last term of the sequence, where the n value is 37. All right, so let's get to plugging in here. I think I'm going to have to do a little bit of work to find that last value in the sequence. I am. I'm going to have to go back to my series formula again because I need to find the 37th term. It's a little side problem. A sub 37, 37th term. All right, well, I need my common difference to go from 3 to negative 7 or from negative 7 to negative 11. That common difference is negative 4. So I plug in a negative 4 for the D value. I'm working on 37 terms, and the original term is negative 3. So my 37th term in this sequence is negative 147. And now I have everything I need to plug into my series formula. The sum of 37 terms is going to be 37 times the first term plus the last term, all divided by 2. So my final sum of these 37 terms is negative 2,775. Whoops, went off the screen there. Sorry about that. Okay, my second example in this section, notice what kind of notation it is. You have total freedom to choose how you want to do this problem. You can work it with our arithmetic series formula. In that case, you need to know what is a sub 1, what is a sub 33, since it's asking for the 33rd term. Okay, so to do that, we'll have to plug in here. A sub 1 would be 6 times 1 minus 15, which is negative 9. A sub 33 would be 6 times 33 minus 15. I'd have to take that over to a calculator anyway. 6 times 33, take away 15 is 183. And so then I can come back to my formula. The 33 terms added together, it's going to be 33 times the first term, negative 9, plus the last term, 183, all divided by 2. And that is going to get me a final sum of 2,871. I know most students aren't going to pick this method. I just think it's a very clear, easy to follow, step-by-step method. I'm going to come on over here since I've got the video on, and I'm going to show you one more time how to put this into sigma notation. If you're good at this, just move on. You can fast forward the video. Sigma notation, I go to functions. Under miscellaneous functions, the sigma notation's in the bottom of the list. The formula uses a, that's a little typo. The formula has a K and a D. I need to use one or the other, so I guess I'll use a D. D is equal to 1 up to 33, and this is 6D minus 15 as the function. So I got a final value of 3,351. Ooh, I need to check something here. Did I make a mistake somewhere along the way? Let me check some other math. I did this in my head, so I may have made a little mistake. Let me go back here. Negative 9 plus 183, 174 divided by 2, 87, and 87 times 33. All right, got to put a pause and see what I've done wrong here.